Okay, today I'm going to talk about subjective refraction, definitely part 3. And in this part 3, I'm going to talk about cylindrical component refractive correction. And I'm only going to talk about in this subsection testing under the fog. I'm not going to talk about testing without fog because testing without fog is definitely part 4, which is Jackson cross cylinder. So basically, cylindrical component of refractive testing under the fog is very good for concept when nowadays it's rarely used in clinical situations, and I think there are very few optometry students who can even uh, have this opportunity to see this charts too. Okay, let's not go further and let's discuss. Okay, cylindrical lenses creates the focal line instead of focal point. You know that, isn't it? We have discussed already in the previous video because cylindrical lens mean a line focus, isn't it? I have already told you, if point focus it means spherical lens. If line focus it means pure cylinder, cylindrical lens. If two focus is here and you find strums of conoid somewhere is circle of least confusion, this is the case of spherocylinder, isn't it? So in case of spherocylinder you will find circle of least confusion and Stumps conoid. There are two focuses. So in this cylinder lenses, pure cylinder without spherical, you find line of focus, not the point focus. So that are used to correct the astigmatism basically. The spherocylindrical combination procedure situation in which the two focal line are perpendicular to each other. Yes, as we have already discussed in the section of Stumps conoid. You have to correlate Stumps conoid here too. The space between the two lines known as Stumps interval. We have discussed it, isn't it? In this picture, the space between two foci. This is called, this is Stumps interval. And the center of it is circle of least confusion. Center in a sense of dioptrically, not linearly. Let me clear you once again. Center of this Stumps interval, the location of circle of least confusion. Center in terms of diopter, not in terms of linear distance. Okay, in terms of distance, this is longer, isn't it? But in terms of diopter, this is basically in the center. That's why we use spherical equivalent is equal to sphere plus CIL divided by 2. What do you mean by CIL? CIL is exactly this gap, which is in Stumps interval. And divided by 2. Why? What is this? This is in diopter. That's why circle of least confusion lies at the center of the Stumps interval. Center in a sense in diopter, not linearly. Okay. So that's within the interval of system. The middle of the conchoid is circle of least confusion. Middle in a sense diopter at a point in which vision is clearest while astigmatism is present. Okay, we know that at that point vision is clearest. Okay, I have already told you. So this is again this picture, and we know it. Two focus there, isn't sagittal focus or tangential focus? And sagittal focus, if it is horizontally, tangential focus is definitely 90-degree apart. If this focus is in this line, then another focus will be in this line. So two things are definitely in a opposite, 90-degree opposite focus. One line is horizontal, then another line is vertically. In the center, circle of least confusion. Okay, this is where the best vision can be achieved, and circle of least confusion position is always middle of the two foci, middle of the two foci, which means middle of the two lines. uh, Middle in the sense of diopter, not linearly. So testing under the fog, whenever we use this 5 method, we do testing under the fog. First of all, first criteria is eye must be fogged. Then we can use these 5 things. And testing without fog is Jackson cross cylinder. See, you will see in your life a lot of MCQs where option A is this, option B is this, option C is this, and option D is this. And the question is which one is procedure is without fog. It's directly Jackson cross cylinder. Okay, It's always, just remember, it's a common MCQ. It's just common MCQ, okay? And sometimes MCQ can be asked to fixed astigmatism dial, then this clock dial and sunburst. Sometimes it's called rotating astigmatism dial, which is rotating T and astigmatic fan and block. Sometimes called combination, which is definitely stenopic slit, and all these things. Okay, not just a combination, but sometimes it can just gives you option ABCD and ask the question. Okay, just remember these things. So today we are going to talk about testing under the fog, which means we have to fog first, and then we can use these five things: clock dial, sunburst dial, rotating T, astigmatic fan, and block and stenopic slit. We will definitely going to talk about this in part 4 of our lecture. Okay. So testing under the fog, what do you mean by testing under the fog? In astigmatic eye, under the fog, the two principal meridii will focus in front of the retina at a different distance, the difference being cylindrical component. While unfogging, both meridian are moved back towards the retina until the point of greatest contrast is reached. The spherical component corresponds to this power, and the minus cylinder is required to bring the other meridian shortest focus. Let me explain. If we fog, then we know that two meridian come in front of the retina. Then we unfog it. Then we slowly unfogging. Then we slowly. What happened then? This meridian focuses the retina, and this meridian is in front of the retina. Just think, this meridian, if I collapse bringing this meridian with this meridian, then what happens? Collapse of circle of least confusion. At that point there is no circle of least confusion. At that point there is only point focus. Okay, for that you don't have to just play with this focal length, do you? No, you don't have to, because this focal length is already here at the retina. Now you have to move this focal line to the this focal point, which is at retina, and then circle of least confusion, sorry, and then Sturm's interval collapses to the point. So let me again tell you. So if we unfog it, and then one meridian, which is this meridian, comes focus, then another meridian is here. Now just just think about it. Okay, just think about it. If one meridian is here and another meridian, now isn't it the difference between these two meridian is cylinder? That's the concept, isn't it? Now you have to move this meridian to retina. Then what to do? This meridian, isn't it a myopic? It's in front of retina, which is a myopic. Then isn't it the minus cylinder is needed to push this meridian to retina? Isn't it? Push this meridian to retina. So that's what the third line is very important, and many of the students don't understand it. The spherical component is corresponding to this power. To which power? The second line. While unfogging, both meridians move back towards the retina until the point of greatest contrast is reached. What do you mean by point of greatest contrast? This means the one meridian touches the retina and another meridian is still myopic. Are you getting the concept? One meridian touches the retina and another meridian, which is this, is still myopic. Now you have to do just this meridian bring to retina without changing another meridian. Then which lens can do that? It's a myopic meridian, then obviously minus cylinder can do that, isn't it? That's what the concept of testing under the fog. I am in this slide. I know I took time, but it's far important to understand this concept. Why I am telling you what is the concept of testing under the fog. One meridian is already in the retina by unfogging it slowly. Another meridian, then this meridian we have to put it back to retina, and from line focus or Sturm's conoid we have to make it from to simply point focus. For this we need minus cylindrical lens. Okay, so fixed dial, astigmatic dial consists of fixed radial dial which present in the form of line radiating away from the center, which means basically like clock, isn't it? So principle the point of image along the line would be extended in a direction determined by the axis of the error. The meridian parallel with the faintest line that is perpendicular to the darkest line denotes the axis of the minus cylinder. My goodness, this is a very important, very important line. Just remember this thing. Okay, just remember this thing. The meridian parallel with the faintest line or the perpendicular to the darkest line denotes the axis of which cylinder? Minus cylinder. It's very gold, okay, stuff. Just remember this. Okay, so for example, if axis of the minus astigmatism error is 180 degree, suppose the vertical line would appear more clear and the prominent while horizontal line would appear fainter and fuzzy. This is example is very good example actually. We first we have already declared if, suppose if astigmatism error at 180 degree minus cylinder, and then what patient must see? Patient must see this second line. Patient must view vertical line more clear. That means horizontal parallel to the horizontal line we have to put minus seal, isn't it? That's the example. Okay, example of this line. Okay, fine. Let's move forward. Okay, clock dial introduced by John Green in 1886 and present with the meridian of space at 30 degree. We know it, isn't it? Our watch is placed in 30 degree interval that coincide with the position of clock hour. So it's very simple. See, each radiant represented a set of 3 lines spaced and distinguished visual acuity of 20. Each line has visual acuity of 20 by 25. Okay. So patient is fogged as indicated earlier, then unfogged until some or all radiant light appear. Okay, so unfogged till vision is 6-9 because that line, because these 3 lines represent 6-9 vision. And then during the unfogging, subject is asked to compare the sharpness and darkness of the line of the various directions. So indicates when the difference between the blackest and sharpest and the faintest fuzziest line is maximum. This is the point of greatest contrast. So what is the point of greatest contrast? While unfogging, when blackest and sharpest and faintest and fuzziest is maximum the difference between them. At that point, it's great contrast. Okay. So unfogging is discontinued at that point when the next reduction of fog makes little or no difference. When we stop unfogging, when next reduction of the fog makes little or no difference between the contrast. So basic, it's very simple rule. See, for axis correcting the cylinder, multiply lesser hour, the most prominent line is 30. For example, it's very simple. If 12 and 6 is most distinct, okay, and then 12 to 6 means, isn't it this? Wait. 12 6 means this line is most clearer. Okay, so then 12 to 6 line is most clearer. So what happened? 6 is smaller, just multiply 6 into 30, which means 180. Put minus cylinder at 180 degree. Finished. Okay, the cylindrical power can be determined by adding the cylindrical lengths in 0.25 steps till the most prominent line and faintest lines in right angle are equally clear. That's the point. There is no difference whenever we put in. And procedure is referred as collapsing of stumps of cone. Just remember this term. It's very important term. Whenever you collapse the stumps of cone, then there is no stumps cone. There is point focus. Okay. The vertical and horizontal line are replaced by the point image. So if you overcorrect the cylinder, then what happens? Previously, which line is clearer? Now again, this line becomes blur by overcorrecting it. So the cylinder may be further refined by refogging increment by 0.2. Check the test. If astigmatism is corrected properly, all lines appear clear, blur under the fogging. So this is the final end point. Okay. If astigmatism is correct properly, all line appears equal, clear or blur under the fogging. It's very important line. Okay. If power is insufficient, the original prominent line will appear first. If power is To grade, the line set reverse the prominence. First, if undercorrected, firstly horizontal line is clear, then it remains like that. But if you put too much cylinder, then vertical lines becomes clear and horizontal it becomes fuzzy. It reverse basically. So disadvantage of the clock dial, what is the disadvantage? Relatively large gap orientation adjustment because it's 30-degree gap, isn't it? So if axis astigmatism error is between 30 and 60, the prominence of the two lines might be similar and difficulty subjective difference is quite difficult. So again, sunbrush tile, which is again fixed, consists of fixed protector in which single line radiates away. The basic advantage is the space at 10-degree angle. The previously in clock dial space is 30-degree angle. The procedure is similar to clock dial. The more critical identification of the darkest line, which is very important. And demerit is difficult to uniform the precise location of the darkest and finest line is because there are lot of means 36 actually radiant line, so it's very difficult to precisely locate the darkest or faintest line for the patient definitely because it's a subjective test, isn't it? So we are coming to rotatory astigmatism dial. So in rotatory astigmatism dial, we are going to talk about two things. One is definitely rotating T, and another is fan and block. Okay. So adjustable line target which can be rotated in the primary meridian and astigmatism are more exactly, more clinically understandable, and great reliability and precision. Basic construction is two groups of parallel line at right angle to each other. It's very important. You will see this in the construction of chart. Okay. So rotatory T, what is by rotatory? Present at fogged eye with the line in a 90 and 180 degree. So we have to have fogged eye. So on fog till patient reports visibility of the line. So patient is asked whether one set of line appear more prominent than other. It's very important. We always do that in every case. If both are equally distinct, the chart is rotated slowly. The subject is asked about the patient position at which set of lines appear to blacker or more visible than in the opposite direction, isn't it? If these are two equally blurred, then we have to rotate so that one set, if this is more prominent and then this is more the maximum blurred. If the difference is reported either at the original placement or newly found position, the axis is refined by continuing to rotate the chart until both crossed lines appear equal prominence of the subject. So we need both at equal prominence, equal blur or equal distinct maybe. This represents the position of exactly 45 degree from the position of principal meridian because in 45 degree it's always equal, isn't it? So to check the position, chart is then rotated in opposite direction until the point equality is reached again. The chart is now meridian perpendicular to the first bracketed set. So we just do the correction test. The numerical advantage of the two bracketed meridian is meridional position of the minus cylinder. First, equal clarity at 45 degree, example. The second equal clarity is 135 degree. Then the position of the minus cylinder axis is 45 plus 30, 130 divided by 2. That's how we understand the concept. See, it's very easy. That, see, how we are going to do this actually is 45 degree away from the principal meridian. At that point appears equal prominence. So we check first for the equal prominence, then again check by rotating in another direction, and we have what we have basically two values for the meridian. To check the rotate the opposite direction in point of reach, the chart is now meridian perpendicular to the first bracket. Then we have two values at clear point, which is 1 and 2. We do just mean point. We calculate mean point, and that mean point is actually cylindrical position of which cylinder? Minus length cylinder, and that's the case with rotating. Astigmatic fan in block. See, it's very important. See, 180 degree, 10 spaces. This is block and this is V. Okay, so this is very sophisticated. So combination is fixed and rotatory, means, see, in this chart this is fixed, this all is fixed, but these three things are not fixed, they can rotate. Okay, okay, they themselves fixed. Okay, fine. So fan to determine the axis of correcting cylinder. Okay, fan, this line is to determine the axis of correction cylinder. Sorry, not this line, this fan determine axis of correction, and maddox b confirm the axis of correction cylinder. It points out the axis of correction, and then which is called maddox b, and block to determine the power of correcting cylinder. Yes, these blocks determine the power of correcting cylinder. See, it's quite important, all the points are quite important. Okay, the space between these spokes are 10 degree. Yes, these spokes are 10 degree, and the maddox v and block can simultaneously rotate through 180 degree. Means these three things can be rotated simultaneously, and these blocks, these are fixed. Okay, so procedure: obtain the best visual acuity putting best spare power in the frame. Astigmatic error is estimated and half of this added to positive sphere, so as to bring the eye into the state of simple myopic astigmatism. We always have to do that. It's a simple thing. Patient asked to relocate clearest line in the fan chart. This gives explanatory direction of the astigmatic error, which is very important. Now we unfuck slowly, and we want to know, patient, which line is clearer. Check the test by refogging. We can repeat it, and the tip of the maddox arrow is to rotate the point to the clearest group, because it's very important. See, we have to ask patient then which line is more clearer, whether this line or whether this line, or which line is more clearer, and then at the unfog or slowly unfogging, and then we rotate this tip towards that clearest line. Are you getting the concept? So tip of the maddox arrow is rotated to the point of the clearest group and directed at the attention of to limb of the maddox row. So rotate it away from its blacker limb until both limbs become clear. So now it's very tricky. So if the tip of the maddox arrow is rotated to the point at clear group, so directed attention is of the limb arrow and rotated away from its blacker limb until the both limb becomes clear. It means what? It means we have to think about these two as a separate wing of the V, and whenever we get one more darker, then we have to rotate this maddox V towards faintest side away from the darkest until when two limbs have equal contrast. That's very important to understand. Until when two limbs have equal contrast. So that's very important. Okay. So directed attention to the limb of maddox arrow, rotated away from the blacker limb until the both limb become clear. This gives the axis of the astigmatism. Finally, you'll get the axis of the astigmatism. Ensure the patient's head is upright. It's very important. And then directed the attention of the block. Now we get cylinder axis. Now we have to just put minus cylinder. Okay. Negative cylinder is added approximate axis, the axis given by V, where those both limbs are clear, and this point out blocks. Then block at certain block number, certain degree, which is correct axis. So negative cylinder is added appropriate axis until both blocks appear clear. First we have to make this wing of the V equal clear, then we have to put minus cylinder so that this block gets equal clear to this block, these two blocks. Okay, so check the test by refogging. Again, if you want to check, you have to refog it and unfog it. Okay, so last, which is stenopic slit. Stenopic slit is quite a good test, and it takes a little bit lesser time. So basically, stenopic slit means the small aperture 0.5 to 1 mm width and up to 15 mm length. So width of the slit approximates to the pinhole. Assume the limited light in the one meridian. So you have already seen that stenopic slit. What is the procedure? Just rotate the slit till patient reports most clear vision through the slit. It's very simple. Just rotate it. And it's one of the perpendicular meridian. Add spherical lens to obtain the vision. So basically, it means it is one of the meridian when it is get clear, and thus add the spherical lens to get best vision. And again, next meridian is right angle to the first meridian, isn't it? This is first meridian, is the next meridian, and rotates in 90-degree, again lens to get maximum visual acuity, just spherical lens. This gives the rx of the two meridian, isn't it? One meridian you put lot of spherical lens, best vision, this meridian power. Again another meridian you put power, this meridian. Now you have two powers of two meridian. This, suppose example, -1, this -3, isn't it? Refraction finished. Then just calculate it. So basically stenopic slit is quite simple. See, I want to conclude it. So basically, in case of testing under the fog, it's very important to understand about the concept of optics in fog. Basically, fog means you are bringing two meridian in front of the retina, and then you slowly unfog, and first meridian comes here and then here. We need to collapse it. And it's very important whenever you are using chart, just remember that always all charts has perpendicular line. If it is Maddox V, there are also perpendicular fan and block, isn't it? So it's always important why this perpendicular line, or some line getting clear, some line getting blur, and why that happens. So it's always better, the best reference is always in clinical refraction, and I have already taken this too. I hope you get a little bit, because it's always difficult first time to get whole of the thing. And I want to tell you seriously, just read this book clearly, Clinical Refraction by Boris, which is very gold stuff. I know it will be difficult, but try it better and just read few books. You will grasp the concept. And the procedure, definitely you have to read all the procedures. Don't rely on this video for the procedure, because I don't think I have explained it in well manner for the procedure. Procedure is very different thing than discussing about the concepts. Okay, procedure, you have to read this book for the procedure. Okay, bis dann, tschüss.